Hello everyone! This is our final lecture. Today we shall solve some theoretical problems via the formalism that we have developed in the previous lectures. I choose three problems for today. The first problem will be concerned with the dependencies of differential magnetic susceptibility on magnetic field at constant temperature and on temperature at constant magnetic field. These dependencies will be obtained for the system of non-interacting local magnetic moments. The other problem will be concerned with the magnetic field dependence of differential magnetic susceptibility at Curie point in the Ising model. And the final problem will be concerned with the dependencies of net magnetic moment Z projection on temperature and on magnetic field at constant magnetic field and constant temperature respectively.
Well, let us try to solve the first problem. Our goal is to plot the two graphs of differential magnetic susceptibility versus temperature at constant magnetic field and differential magnetic susceptibility versus magnetic field at constant temperature for the system of non-interacting local magnetic moments. What should we do? First of all, recall the expression for magnetization of the system of non-interacting local magnetic moments. Next, we should write the definition of differential magnetic susceptibility and differentiate the magnetization with respect to magnetic field. After that, we can analyze the expression obtained for differential magnetic susceptibility and draw the following graphs. On this slide we can see two pictures. On the left side, we see the graph of differential magnetic susceptibility versus temperature at constant magnetic field. And on the right side, we see the graph of differential magnetic susceptibility versus magnetic field at constant temperature. So the problem is solved. Our second problem is more difficult. We should find the magnetic field dependence of differential magnetic susceptibility of ferromagnet at Curie point in the Ising model. What should we do? First of all, let us recall the expression for free energy near the Curie temperature. Next, we should substitute Curie temperature in this expression, differentiate it, and find the order parameter x. Here, we see that it corresponds to the minimum of free energy. Let us write the expression for magnetization and differentiate it with respect to magnetic field to obtain differential magnetic susceptibility. Finally, we find the dependence of chi on the magnetic field. We can see it on the picture on the right side. So, we solved the second problem as well. In our final problem, the projection of local magnetic moment on the arbitrary z-axis can assume the five different values from -2 μ0 to +2 μ0 in a magnetic field parallel to the z-axis. Our goal is to find the net value of μz and to plot the graphs of μz of h and μz of t. Recall that we just solved such a problem in our third week, lesson 1. However, in the previous problem, the projection of magnetic moment on z-axis could take only two values. Anyway, our Hamiltonian has the same form. Let us make some mathematical manipulations according to the interplay of quantum mechanics and statistics. See the appendix at week 3, lesson 2 for details. Finally, we obtain the net value of the magnetic moment operator. Let us graphically analyze this expression. You can see the dependencies of magnetic moment operator on temperature at magnetic field which is greater than 0, left picture, and at magnetic field which is less than 0, right picture. These graphs are symmetric with respect to t-axis. The μz dependence on magnetic field at constant temperature has the following form. See the left picture. This form of graph is very similar to the one that we previously obtained for isolated local magnetic moment, which projection on the arbitrary z-axis could be up or down only. See our first lesson at week number 2. Therefore, we successfully solved our final problem for today.
Well, our course came to its end. There is only a final quiz ahead. So, I thank all of you for your attention and I wish you continued success in your career. Bye.